An object moves from the point 0, 0 along the curve y equals root 3 sine x. The distance d travelled along the curve is given by d of t is the integral from 0 to pi t of 1 plus 3 cos squared x, where d is measured in meters and t is measured in seconds. Now, if this is the distance, to get the speed, we can differentiate. We need to note there's a pi t up here. I'm going to let u be equal to pi t, and du dt would therefore be pi. So we then get that d of u, with the integral from 0 to u of the square root of 1 plus 3 cos squared x dx. And then if we're thinking about dd dt, which would be v, that would end up being du dt dd du. And the fundamental theorem of calculus tells us that this would just end up being the square root of 1 plus 3 cos squared u. And of course, u is equal to pi t, so we'll replace that with a pi t. And du dt is pi, put a pi in front there, and that's what we get. So essentially what we want is just dd dt, given that t is equal to 1. So that's just going to be pi times the square root of 1 plus 3 cos squared pi. Now, cos of pi is -1. We square that, we get 1, multiplied by 3 is 3, add 1 is 4. And so this is 2 pi. If we gave a calculator answer, 6.283, and that would be, in meters per second, 3 decimal places. Use the increments formula to estimate the distance travelled by the object between t equals 1 and t equals 1.02. So delta t here is 0.02. We're after delta d, which is going to be approximately d dd dt times delta t, and so that is going to be dd dt at 1, which is the answer to the first part of the question, times 0.02. So we know it was 2 pi, so 2 times pi times 0.02 gives us 0.126 meters.